We're working in Supplement C on the problems. This is our first problem, and we're working on slides 7 and 8 in Supplement C. We're going to be looking at drawing a decision tree. A decision tree is a graphical model used to determine our estimated or expected monetary value. It uses squares or rectangles as our decision points, circles as an event node, and a branch or a straight line where we're going to write our probability. These symbols are very important because it actually tells us what there is, what each thing is, and it's their identifier. So if we take a look at slide 8, we're looking at the problem. WGIV giveaway 93. This is a local radio station, currently has a giveaway contest underway. Once a contestant is selected, he or she is given two choices: take $93 in cash or pick one of three envelopes. The contents of those envelopes are $500, $100, or merchandise which is estimated to be about $20, which I believe is probably crap. You want to draw a decision tree for this decision and then decide what decision should be made to achieve the highest expected monetary value. What would you do before we even draw the decision tree? Would you take the envelope or would you take the straight cash? I'm one of those people who is very low risk. I would probably take the envelope. Let's take a look now at that decision. What do we need to do? We're going to start by drawing our decision tree, and our decision point, we said, was a square or a rectangle. Now, you don't have to write anything in there, but I'm the type of person who needs as much help as possible. So I want to remember what I'm looking at. So I know it's going to be cash or an envelope. So I'm looking at my decision points. Do I want to take cash or do I want to take an envelope? So those are my two events that can happen. I can take cash or I can take an envelope. So we're getting our decision tree built here. And I know that if I do take the cash, it is a probability of 100% that I'm going to receive $93. Notice that the branch is the line with the probability written above it, and the outcome will be the $93. Now, the envelope, I have three possible outcomes if this takes place. I might receive $500. I might receive $100. I can get that envelope with, the coupons and everything else. That's worth about $20. Now, because we want to get as close as possible, we're not going to use decimal points here. We will be working with fractions, and we have a 1 in 3 chance of getting $500, a 1 in 3 chance of getting $100, and a 1 in 3 chance of getting $20. This right here is your decision tree. There's nothing more to it. You have your decision point, your event nodes, and then the possible outcomes. Dealing also with our probabilities. So using this decision tree, we are now going to do our expected monetary values. There we go. Expected monetary value. Let's start with our expected monetary value for cash. What was the probability? Probability was 1.0. So I have a 1.0 chance, or 100% chance, of getting $93. Do the math. I can actually do that one in my head, and it is $93. The expected monetary value, if I take an envelope, is a little bit harder. If you take a look, I have 3 different options that can happen, or 3 different outcomes that might occur. I have a 1 in 3 chance of getting the $500, a 1 in 3 chance of getting $100, and a 1 in 3 chance of getting $20. So if we take a look at this, my expected monetary value is a 1 in 3 chance of getting $500 plus a 1 in 3 chance of getting $100 plus a 1 in 3 chance of getting $20. Now, if we take a look back here for just a minute at the definition of expected monetary value, which is slide 5 in supplement C. It is found by summing for every state that can occur the products obtained when the probability that the state will occur is multiplied by the amount that is expected to be received if the act is taken and that state occurs. So if we take a look, we have the probability times the outcome if that occurs. So it's a 1 in 3 chance times that, summing up each and every single one of those probabilities times that possible outcome. We're then going to add them up. So doing a little bit of math here, 1/3 times 500, which is 1 times 500 divided by 3, and this is looking at a monetary value, so we only have to take it out to 2 decimal points, is 166.67. 1/3 times 100, or 1 times 100 divided by 3, is 33.33. And 1/3 times 20, or 1 times 20 and then divided by 3, is 6.67. If we then take all of these and add them together, we should have $206.67. So our expected monetary value for choosing an envelope is $206.67. Now, what would you do? Would you take the cash, expected monetary value of $93, or take an envelope, expected monetary value of $206.67. Now, you're never going to get that amount of money because you're going to get $500, $100, or $20. But because the expected monetary value is higher, you should probably take the envelope. Now, this is a game of chance here, etc. I am an extremely low risk person, so I still would probably take the cash. Cash in hand is better because with my luck, I'm going to end up with the $20. But you need to decide this for yourself. So this is the end of our decision tree problem in supplement C, dealing with slides 7 and 8.